In this problem, we have a pipe supported by a frame, and the pipe has a diameter of 3 feet, and it's supported every 16 feet by a frame that just is attached at 2 points here, and then attached to one another, 2 members here. And so, the first thing we need to do is do a little geometry to figure out where points B and D actually are. So we know that the pipe is sitting in this wedge here, and we know that this distance is 8 feet. This distance is 6 feet here. If we might draw the triangle, here's where point A is, but we'll draw the triangle here. And then that means that this is 10 feet. And we can then figure out what this angle is in here by taking the cosine of 6/5 or the inverse cosine of 6/5 or 3/10. And so that gives us this angle here is 53.1 degrees. And then we can figure out this length here and this length here, which will be the same, by knowing we have this triangle here, and this is the radius of the pipe, which is 1.5 feet. We know this angle here, and so we know the tangent of this angle is this divided by this, and this is what we want. And so then we can find the distance from here, the length of this turns out to be a nice even 3 feet. And same thing for over here. So now that we have that, we can write the position vector for B, and so for B, that's minus 9. I think, why did I put CM here? I'm thinking center of mass. Hasn't got to that yet. Minus 9 CB, and I did the same thing here. CM. What am I thinking? CD, and so RB is 0 minus 6, 0, and then we have a unit vector from C to E, so we go that distance, C to D along that unit vector up here, and we wind up with RD is at 12/5 and minus 36/5, where that point is. So it's RC plus this distance here. And then we can also figure out where RG is. This is, I defined a new point RG, which is where the center of mass of the pipe is. And that is at RB plus 1, the radius of the pipe in the horizontal direction. And then I defined a unit vector from G to D here, and that's just 3/5 and minus 4/5 is this a unit vector from G to D. We need that because we need FD is in that direction. We needed it for this. So we know FB is in the horizontal direction because there's basically no friction force acting perpendicular to these elements. And so FD is perpendicular to the vector from C to E. So we have that vector here and that force in that direction. So we have lots of equations and lots of unknowns here. And how I solved the problem was I looked at the whole structure. So we have the external load is now so it's the pipe has weighs 500 pounds per foot, and this hanger is holding up 16 feet of it. So our force at on the center of mass of the pipe is 16 times, or basically 16 times 500 in the minus y direction. And so we kind of some forces and some moments. And I introduced a little bit of notation here. So the first set of equations I did was the entire body. So on the entire body we have Fa and Fe and Fg acting. All the other forces are internal forces. So we just have 3 of them, and they also create torques. And then I looked at body. At body. Let's see here. Let's see here. BG. Okay, I looked at body. I looked at the pipe. Okay, so at the pipe we have force D, force B, and force G acting. Right? And so that's BGE, and so those also have moments. Although they should all cancel out because they all should act through the center of mass here. So then we have the I looked at then C, D, and E, the bar, the inclined bar on the right hand side. And I introduced a new notation here. This is minus D, because when we sum forces and sum moments, we need minus FD in there, because it is equal and opposite to what the D was in this part, because it's an internal load. We need, if we add all these things up, we need that these internal loads basically cancel out. External loads act the same way on all members, but internal loads have equal and opposite reactions. So in the last set of equations, we need to replace FD with minus FD. And so that's what this notation here is. And so we get 3 equations, 6 equations, 9 equations, and we have 9 unknowns. We're only asked to figure out what Fe and Fc are, and Fe is minus 2,000 pounds in the horizontal direction, 2,250 pounds in the vertical direction, and Fc, we were asked to point the force, the internal force on between the members, and it is minus 4,000 pounds in the horizontal direction and 5,750 pounds in the vertical direction. So we have pretty large load acting there to keep these things from breaking apart. So whatever pin is in there, it's going to experience a lot of force. And so let's see here. This thing is it's actually acting in this direction here. It has a minus horizontal component, so it'd be acting like this. So again, it's trying to hold these 2 bars together with a lot of load.